What's up, party people? Today's late night video is brought to you by a good supper, and in it we'll be speaking about similarity of triangles. Alright, so let's get into it. Okay, so to prove that two triangles are similar to each other, we need two things. Alright, so firstly, I need to get the right color pen here. Firstly, we need that all the pairs of corresponding angles must be equal each other. So what that means is that not only must the angles be equal each other in the two triangles, but they must also be in the same order. Corresponding angles must be the same. Okay, great. So that's our first thing. And our second thing is that all the corresponding pairs of sides, right, so the length of our sides, must be in proportion. So not equal, in proportion. Forgive my spelling, I don't know, proportion, okay, spelled roughly like that. Luckily we're doing audio as well. Okay, so once again that means that not only must they be in proportion, but they also have to be in the correct order to one another. Okay, so let's have a look at what that actually is. So let's have a look at A. So the angles must be the same. Alright, so we get given two triangles. This is triangle A, B, C, and then this triangle is DEF. Okay, so we can see that these aren't completely the same triangle because the one's obviously much bigger than the other one. Okay, so it's not congruent. Congruent means that they're identical triangles. Similar just means that the angles must be the same and the sides are in proportion to one another. Okay, so let's go for the angles. So just using these symbols to demarcate the angles. All right, cool. So we have angle D is that one, X and Y. Okay, so let's say this is how we've set up our triangles. Okay, so we can see from here that angle A is equal to angle D, right? Same symbol. Okay, then we can also see that angle B is equal to angle E. Same symbol, right? And same logic, angle C is equal to angle F. Okay, cool. What this means is that we have two equiangular triangles. Okay, so we fulfilled one of the criteria for similarity, right? So our angles are the same. Okay, cool beans. We'll get into the order of them now. It only matters once we know the length, so we'll get into that now. Okay, so let's look at our second guy that we have to do, right? And that's the sides must be in proportion. They don't have to be the same, not identically the same, just in proportion. Okay, so we've got two new triangles. All right, so just for ease sake, I'm just going to label these the same, D, E, F. Okay, so we have angle A, B, C, and then that guy, that guy, that guy. Okay, cool. So we're going to look at the sides now. So let's say AB is equal to 3, BC is equal to 5, and AC is equal to 7. All right, so DE is equal to 14, 6, and 10. Okay, so we need to see if they are in proportion to one another. Okay, so what we're going to do is that now we have to pay attention to the order of things. So we can see that the 3 lies between my dot and my Y. So I need to find the corresponding pair of that one. So here's our dot, here's our Y, so the one that lies between that is our 6, right? So if we're looking at our corresponding pairs, okay, you don't have to write this in a test, I'm just doing it for explanation's sake. All right, so AC should be proportional to AB. AB, right? Because it's in between the dot and the Y. AB should be proportional to D and F. Okay, so that's one of our pairs. Now we look for the other one. Let's look at this 5. Okay, so 5 lies between Y and X. Okay, so we look for our Y is over here, right? And our X is over there. So we've got 10. So we're just finding our pairs for now. So we've got BC should be proportional to EF. And then we're going to find our last one is obviously has to be this one because it's the last one left. But just for the sake of explanation, it's between the dot and the X. This one's between the dot there and the X there. So it's 14. Okay. So what we have is sorry, let me just keep the order the same. AC should be proportional to DE. Okay, so these guys should be in proportion. Okay, so these are corresponding pairs. So if I had another triangle that looked like this, an exceptionally similar looking triangle, okay, and we had, let's say, so those look exceptionally similar. Let's call that X, Y, and Z. Okay, and I'm going to get to that right now. So just keep this in mind. It's one more extra triangle. Okay, so let's see if there is a proportionality between them. So how do we find a proportion? So let's go, what is the proportion, right? So we're either going to be timesing by a number or dividing by a number. Okay, so how we figure that out, and remember that proportion has to be exactly the same. So what we do is, we notice from this triangle to that triangle, right, our sides have gotten bigger, right? We have 3, 5, and 7 on the first triangle, and then 6, 14, and 10. So those are much larger sides. So we're going bigger. So what we're going to do, we're going to put the length, so whichever one of these is bigger. So over here, these guys are our bigger sides or our longer sides, and these are smaller sides, right? So we're going bigger, so therefore we put the bigger length on top. So we go DE divided by AB, okay? And that's going to give our proportion. And if it's similar, we put them, they should all be the same. The proportionality between them should all be the same. So we got EF over BC, and then lastly we got this one, which is then DE over AC. Okay, so let's fill in our values. So AB is equal to 3, and DF we have is equal to, DF is equal to, where is this thing? Sorry, 6. Okay, and then EF is equal to 10, and BC is equal to 5, and then we have 6 over 3. Sorry, but that twice. DE is 14 over 7. Okay, there we go. So it gets a bit tricky, as you can see. Just make sure that you're doing everything in the right place. Okay, don't be like me. All right, cool. So now let's just simplify these fractions. 3 goes into itself once, into 6 twice, so we're left with 2. 5 going to itself once, 10 twice, and 7 goes into 14 twice. So we can see there that the proportionality is the same. So we can therefore state that our sides are in proportion, and the ratio of it is 1 to 2. So in other words, we're just timesing the sides by 2. Okay, so now we've solved our 2 things. Okay, so I just want to show you what would happen in this triangle over here. That's slightly different. Okay, remember we said that the corresponding sides, they must be in the same order. So in other words, they must be between the same angles. So let's look here. So we had AC, right, which was 7, is between the dot and between the X. Okay, let me use the same color as AC. All right, so between the dot and between the X, that's the dot there, there's the X, we have a 6. So this one says that it's corresponding to a 6. Okay, so let's see now BC is between the y and the x. So we find the y and the x. This one's telling me it's 10, and we can already see we have a problem, because if we go AC, we went from a 7 to a 6, right? So it's getting smaller. But if we go from a 5 to a 10, we're getting bigger. So this one here is not similar. Even though we have the similar values and our angles are the same, it has to be the same order that matters. Okay, cool beans. All right, so let's say, for example, like, so this is how we prove that something is similar. So a lot of the time they're going to give you a triangle, or a set of triangles, I should say. So 2 triangles, and remember, they don't have to be drawn to scale. Okay, so the bigger one could actually be in terms of how they write it, the smaller one, and angle your, okay,